Welcome students to the course on Applied Computer Vision. So this is an introductory computer vision course that provides you the idea about the basics in this field. So in this course, this first lecture is the introduction. We will describe the basic ideas and what we are going to study over here. Okay, so we will discuss over here in this chapter what is computer vision, and we will see what is the state of the art. The word state of the art means that what is currently happening in this area, because remember, many of the computer science fields or sub branches, they are very recent areas. So like those areas, computer vision is also not so old. It is hardly 15 to 20 years old, whole subfield of computer science. So we will be seeing that what is currently happening in this area, and then we will discuss why computer vision is difficult, and we will see the course overview, and we will also discuss the software that we are going to use over here. Clear? So computer vision, it is basically we will discuss, first of all, when we are going to discuss the computer vision, we will discuss the overview of the vision, how our eyesight works, and we will give some example about the state of the art, what is currently happening in this field, and we will see a little bit of the projects. So remember, computer vision is a field that is based on the image processing course. So if you haven't taken image processing course, then this area is not for you. This course is not for you. First you have to take that course on digital image processing, then you come over here. So computer vision, it has applications in many areas, and it is related to machine learning. That is another course taught in ICN, and it is also related to many other areas like graphics or photography or optics, and also it is used in combination with other fields like in robotics, human interaction, and in the medical and neuroscience. So what is itself the computer vision? Computer vision is basically the area that deals with the development of two things, theory and algorithm. So we discuss the theory, and then we try to convert that theory into some practical algorithm or software. So that algorithmic basis, and what we do is that these two things that we do, they help us to get useful information about the world around us, the 3D world. So 3D world over here, it is used about the world that is around us. We call it 3D because this world that is around us, we can represent any point in this world using three coordinates, x, y, and z. Whereas a 2D image or 2D world is something that is drawn on a page like a graph paper, because there are only two axes, x and y. So basically, let's read it again. Computer vision deals with the development of theoretical and algorithmic basis by which useful information about the 3D world can be automatically extracted and analyzed. So what we want to do is, in computer vision, we try to create the theory and then the software that can help us to get the information from the world around us, the 3D world around us. And this information that we get, it should be obtained automatically. We should not help the computer. Okay? No one should help the computer. Computer should be able to do it automatically. So automatically extract means to get. So automatically extract the information, and then it can also analyze it. So analyze means, for example, if this is the picture over here, so you see this picture, What information can be obtained from this? The information that can be obtained from this picture is that there is a person over here. So this person is standing, okay, not sitting. So this is one information that is extracted. Then in this picture we can see that there are chairs. So these are the information that we get or extract from the image. So we try to create an idea about the real world from single or multiple images. 2D images means normal paper based images. Images that are printed on the pages, we call them 2D because it has only two axes, X and Y axis. So we use this to make an idea. So we use these images to make an idea about the real world. And then this idea helps us to do two things: to get some information automatically, and then we can analyze that information. So what information we can get from the image? For example, there are chairs, there is a building with glass, there is a person in standing position, and we can analyze it further. So what analysis can be done? For example, the person is moving. Okay, so this is not directly clear from the image. We analyze it. We do some further thinking, some further processing of the image to get some extra information. So analysis or to analyzing a picture means that you process it to get some information which is not so clear. So one information we get is, for example, the person is moving. Another more clear information is that the person, it is in front of the chairs. So person is near to the camera and chairs are far away. So these are some of the information we can get from the images. So computer vision is a very interesting field. It has an application in many places. You will see in the further in the lecture. This area is also sometimes called as, computer vision is also called as image analysis. So because we are most of the time dealing with the images, one image, single or multiple images. It is also called sometimes as scene analysis, computer vision, because scene is also same word used for an image. So one image, if it is representing some particular place, we also call it scene. And another word we use sometime instead of analysis, it is understanding. So image understanding, it is something that we try to find the meaning of the image. Clear? So this over here that you see, it gives an overview about the computer vision. So this is a typical definition of the computer vision that you can expect. The computer vision system, it normally has three main parts. So the main parts of a computer vision system is that it will have a scene. So scene is basically a place which you want to observe. Okay. So in the previous image you saw the scene. It was some chairs, one person moving, some outside scene. Okay. So other than the scene, there are two more things. One is the sensor that will sense or detect the image. So sensor typically is the camera or the video recorder or camcorder. So the sensing can be done by in the form of images, or it can also be done in the form of a video. Okay. So this is the second part, and then the last part of this computer vision system is the computer plus its software algorithms. Computer itself is nothing. Computer also needs those sophisticated or important software that can get the meaning from the images. So what type of information we can extract or get from the scene over here? So we can get the information like there are fruits in the scene. One of the fruit is red and it is apple, and the pear maybe it's rotten or it's maybe bad, not not eatable. So these are the three main components. There is one more component that is needed, but it's not a must. So we don't write it normally. So there are three parts of computer vision system, but there is one more thing needed sometimes is illumination. Illumination means some sort of source of light. So that source can be natural like sunlight or artificial like the tube light or the bulbs at our homes or in the offices. So that is also source. And there can be one more source. For example, there is no light, but there can be a temporary, for a millisecond, there is a light in the camera, the flash. So the flash will turn on for just a millisecond, part of a second, and it will make the image brighter, take the image, and then turn off. So this is the introduction about the three parts of vision system. So you see over here a small image. If I ask you in the normal class, I ask the students take 10 seconds, for example, go through this image and note down the things what you can observe in this image. Okay. So what people note down normally is that there is some sort of forest, lots of trees. There is some Chinese style building. Okay. And then there is a lake with water. And then there are some stones. These are the important components. But there is something that is most important that I want to show over here is that if you see over here, the water has got the reflection of the building. So there is a reflection of the building in the water. So the problematic part over here is that this is why the computer vision is very difficult. We will see many times this thing in the future, that to get the meaning from the images, it's not always easy. Most of the time it's difficult. So here you see there is an image where there is a house, but there is a shadow of the house in the water. Now this is difficult, how to manage it, how to know what is the boundary of the house, or how to know how many houses are there inside this image. So this is something very troublesome, and this is a difficult part for the software to do. Okay. So before we go into details about the images, first of all we will discuss very briefly. You may have taken other courses. If you have taken some other courses with me, maybe you have seen this thing many times. So we will discuss a little bit about the human vision, how the human vision system works, how the eyes and the brain work together. So human vision, it has two main parts. So there are our eyes that work as our sensors, and then there is brain that is like the computer. So eyes, they are like sensors, like we have the cameras, and then there is the brain that works like the computer hardware plus the software. Okay, maybe you can say that the physical brain is the hardware, and whatever is inside the brain in terms of electrical signals, those are basically maybe the software part. So how it works is that the image, it comes out from the outside. The brightness or the sunlight, if you go back, so sunlight, it strikes on some object. For example, there is a light, maybe from sun or from some other source. This light falls on an object. So maybe the object is the apple. So apple when the sunlight strikes the apple, some part of this light is reflected. Most of this light is absorbed. Only one color is reflected, which is the red color. All other colors are absorbed. So one color is reflected, the red color, and that color, when it comes to the camera or to the eye, it goes inside the eye or inside the lens of the camera. So what happens inside the eye? The red color reflected from the apple, it comes from the outside and it passes from the front of the eye. And in the front of the eye, there is over here something which is called as the lens. You see the word over here, lens. So what does this lens mean? This is the same lens, you can say the functioning is same as we have in the glasses. Okay, so the lens, what is the job of the lens is that the light that is coming from the outside, it should make this light to focus at one point at the back of the eye. So it will create an image at the back of the eye over here. So this back of the eye where the image is created, it is called as retina. Clear? So those people who have a problem, just like me, who have a problem with their lens, so what happens is that their lens is not working properly, and the image that is created by the lens, it is maybe over here, much ahead of the retina, or it tries to make an image much behind the retina, far away. In both the cases, you will not be able to see the clear image, and the image that is seen is blur, not clear. Okay. So when this happens, the image is not clear, then we use an external lens over here. That's why we use glasses. So glasses are used, and that's why each person will have his or her unique glasses. The people, they can't share each other's glasses. Okay, so the glass that we use, it is trying to correct the lens over here, and the image is created at the correct place. Okay, so what is a retina? Retina, you can say it is a very beautiful thing from the nature. It is a wall that contains millions of small cameras. Millions, not one or two. Millions of cameras are over there. So each cell that is in the retina, it will take the color value, it will take the value of the image, and it will store it as electrical signal and then pass it to the brain. So eye, basically it will take the value of the whole image, and it will be millions of values, and it quickly passes those values to the brain. So when it reaches the brain, over there is one part of the brain which is called visual cortex, and that visual cortex decides, decodes that image, and we can see those objects. All the signals that are transformed in the retina and are converted into electrical signals, they are transferred to the brain through the optical nerve. So optic nerve is a small wire or a nerve that transfers electrical signals from the eye to the brain. Is it clear? So you can pause the video or go back and see it again. I suggest that you can turn on the subtitles below, and it will help you. So this was the functioning of the brain, but there are problems with this functioning also. Our brain and the eye, the vision system made from the human eyes and the brain, it can easily be tricked. It is not reliable, and it has some limitations. So here is one example. I ask you to take one of these black dots and look at that dot for 5 seconds. Just focus on one black dot, don't look around. So when you focus on the black dot for a very long time and then suddenly you look out to the other objects, you will feel as if all these things, they are moving in circles. Okay, so they are moving in circles. So, practically they are not moving at all. You can take a camera, for example, take the photo and you will see that they are not moving. But the human brain, it gets tricked. There are some weaknesses of the human vision system. So one of the example is over here. Clear? So this computer vision, before we go to its details, we will study the terminologies or the definitions that we see in this area. This slide is very, very important. It has many questions for your exam also. So related to the computer vision, there are two more terms that you must already know. And all of them, because you are from the ICN mostly, so all these courses you study somewhere. So computer vision is this course. One more term that is related to this is image processing, and this is the course you studied as digital image processing. So image processing, basically what you studied over there was you take an image, any 2D image. So 2D means two-dimensional. So take an image and you do some application on that image and modify that image. So for example, you filter that image, or you take you pass it through high band pass filter or low band pass filter, or whatever it was. So what you used to do in that course mostly was that you transform the image and convert it into another image. So mostly what you were doing is take an image, do something and convert it into another form. But still it is an image. Okay. Now computer vision, it is a little bit different thing. In the computer vision, what you do is, so there is a mistake over here. Let me correct it. This thing that you see over here, it's attached wrong. It will come down and this one will go up. So computer vision, as you studied previously in the slide before somewhere, that it means that you take the images, one or many images, and you try to create an idea about the world from that image. So if you go back, there was an image over here. From this image we tried to make an idea about the world, the real world, from where this image was taken. So the image over here, it can give me the idea that the person is standing in front of the chairs. Chairs are far, far away, and then the person is moving. He's not sitting, standing, and the weather is maybe daytime, not evening or night time. So many things I try to find out from the image. Similarly, this image, it gives me an idea again that this is the daytime. There is thick forest. There is a building, and the building has a reflection in the water. So there is water also. So many things I get from the images. So computer vision is basically getting a lot of information from the images and try to create a model. So you try to create a 3D model or 3D world from the images. So this model, maybe you don't create it as a real image. You don't try to create a 3D model yourself. You can sometimes store this information in the memory somewhere. One other thing that is opposite to the computer vision, it is to convert the 3D model or 3D world into the images. and this is basically the computer graphics. So computer graphics, basically it means that you have some idea or representation about the 3D world, and you try to show that world yourself to the users. So just imagine if you have ever played some computer game. Most of you maybe know computer games. So just imagine there is a car racing game. In the car racing game, there is a car that is going on the road. So when you press right or left arrow, the car is moving to the right or to the left. So this whole thing is basically that there is a computer model that represents a whole world inside. Some programmer created that 3D model in the computer, and computer shows you one part of that model with the help of an image. So you see your car because there is an image that is shown to you. So when you move the arrows left or right, the image changes and your position in that world also changes. So basically the computer graphics is the opposite of the computer vision. So all of you have studied smart computer graphics. Most of you have studied this course, smart computer graphics. That is the opposite of computer vision. So remember, in the computer graphics, what we do is that representation of the 3D scene, we try to represent it as an image. Whereas the computer vision, this course, we try to get or create this 3D model or 3D world using many 2D images. So we try to recover information about the 3D world from the 2D images, and it is the inverse problem of computer graphics. And finally, we discussed earlier, image processing is to operate on one image to produce another image, and there are many techniques that we use. For example, to remove noise, denoising, deblurring. Some of these concepts we will see in the future chapters over here also. And also we try to do something like enhancement of the image or doing some convolution. All these things are image processing. I hope it is clear. You go back, repeat this slide. If it's still not clear, you can ask questions in the group. Here is another example. What we do with the computer vision is that basically we take an image, a normal two-dimensional image, and we try to create a model from that image about the world. So what a model can look like. So let's say this is an image of a person. So model can be of many types. One model is that I try to find out the depth of the objects. So for example, in this image there is a bookshelf, some more things, and there is a person. So person here is sitting in the front and all other things are far behind. So this is one model you see over here. So model is basically storing some information about the real world that we see in the image. So image itself, our brain can find these things easily, but it's not easy for the computer program. Our brain can easily find that human is in the front and the wall is at the behind, or the bookshelf is far behind. But for computer, all of these are pixels. So it's not easy to find out. One more thing that can be found from this image is the face of the human, and then there are the human eyes where they are inside this image. So these are basically some examples of the 3D model. Here are some more examples. There is one more example, computer vision. So what we do in this area in computer vision is to make computers understand the images and videos. Okay. So here you see cars. So what can be difficult about computer vision? One thing maybe you may not feel over here difficult about computer vision is that Maybe your software, it can detect that there are 3 cars over here in computer vision. But it's not so easy to detect that if the cars are in the parking or they are moving. It's not easy. And one image is normally not enough to find out. So again, same thing is repeated. 3 things inside the computer vision system: scene, sensor, and the computer system. Computer system means the computer hardware and the computer vision algorithm running on that hardware. So why it is difficult? Computer vision. Here is another example. You see over here in the image, what is it? The image. What you see over here? The first word, most of you in the class, maybe they would say there is an accident. But for the computer, the image it contains, image is made up of pixels. And these pixels, they contain some values. So there are lots of values in this image. So we can say that normally in computer vision, an image is basically something that can be represented as a matrix. So this is an image. I can represent this image as a matrix over here. So you see there are a set of values, rows and columns. So these values, they basically make a matrix. Clear? So what's the problem? The problem comes over here is that from these pixel values, maybe a computer program or algorithm can find out that there is a train. There is a train in the image. Okay? It is possible to find it out. But it is very difficult to find out that the train is not in a normal position and there was some accident. Now that's a difficult thing to do. That's the difficulty. So why we need to study computer vision? So computer vision we need to study because images now they have become very common, and videos also. Everywhere. Every second person now has a camera, a mobile phone, and mobile phones mostly come now with a camera. Not even one. There are mobile phones with 2, 3, 4 cameras. So you can just imagine what will happen after 30 years or 50 years. Cameras will be everywhere. So that's why the role of computer vision will increase, because computer vision is the field that gives the computer software the ability to find information from images. The images will be so many. Even today there are so many images on the internet. But in the future there will be so many the images that humans they cannot process that much information easily. So for this we need lots of software programs. Okay, so therefore we need the applications that can manipulate images and videos that can help the humans to do many important things. And another thing where computer vision can help is that it can help to extract or get information from the images is in the surveillance. So surveillance means the security cameras. For example, in this university also, there is one security room where they have lots of computer screens or TV screens, and they are monitoring the whole campus. So every building, every important point in the buildings and outside, they monitor if the person's moving around, going or coming, everything is monitored. But there is one problem with the surveillance. Security guards, they are human, they are not perfect. And a lot of time they are not active, they cannot watch the screen all the time. So for this purpose, the importance of computer becomes clear, because computer software, it is not tired, computer software do not need some rest time. It can work 24 hours. So this is one usage. Another usage of computer vision is to create the 3D representation of buildings and some other objects. So the example can be like if you have used Google Maps. So there is one Google Maps that you can use on the internet. There is another one, Google Earth. That is a software you install on your computer. Both these softwares, they allow you that you can see many important places. You can see them as a 3D model. Just try it if you haven't done it before. You can see, for example, the Eiffel Tower, and they have created a 3D model of the Eiffel Tower. Or you can see the Leaning Tower of Pisa, or you can see the London Eye. All these things you can see in the model clearly. Similarly, you can use these techniques, these softwares, to capture motion. So motion capture softwares, they help that they are part of the surveillance also. They can help if there is some sort of motion in the observation area, in the images. Clear? So why we need to study this computer vision? We need to study it because it's really interesting and it tries to solve some very cool problems, set of problems. So you see over here this image. The goal of the computer vision is to write such program that can interpret this image correctly. What does interpret mean over here? The correct information from this image to get is there is a train, but there was a train accident. So accident is more important over here. Clear? So to make sense from the picture, it's very important. So what we want to do is that we want to extract meaning out of one or sequence of images. And this is different from image processing that you have studied earlier. Because in image processing, you are normally concerned only with transforming the images. But here you are more concerned with getting information from the image. Image processing operations, we will study them over here also. So operations like blurring, thresholding, we will study them over here in computer vision, part of computer vision algorithms. This will be one part of the chapters because this is important for us to continue. So now I show you one more image. You can pause the video and look carefully at that image, and again I ask you to note down on a page what are the important things that you see in this image. Clear? So this is the image you see over here. Quickly write down what are the important things you can note down, maybe in 10 seconds. Okay. So most of you would have given me the information like there is a sofa, chair, table, some sort of dish on the table. Then there is some sort of telephone with a fax machine maybe. And there is a laptop and table lamp, books, curtains, bed, TV. Many things you have noted down. So a lot of computer programs, they can also detect these things. Some things they can detect easily, some other things a little bit difficult. One thing, the obvious things, it is easy to detect, like sofa or the bed or laptop or chair. But there are some other things that our brain can easily find out or detect, but for computer it's not easy to judge. One thing is that there is light coming from the outside through the windows. and we can say that this is the daytime, not the night time. Okay. And then there is another thing, that light is coming from the two sources, one through this window, and then there is some light coming from over there. Okay. So two source of lights. And then there is one more thing, that sometimes there is some reflection on the floor of this light, and this reflection, it is not a source of light, it is basically just the light coming from the outside that is reflected. These things now are not easy to do in computer vision. So what we can do, we can identify many items over there and we try to recognize them, but it is not easy to detect the time of the day or the space or the objects all the time. So we will see a little bit about the current state of the art. I explained earlier, state of the art means that what is the current state of this field. So can computers, this is a typical question asked many places online also, that can computers, they match human vision, or can they beat, they can be better than the human vision? Is it possible? The answer to this thing is that mostly computer vision is not better than human vision. Most of the time, no. Sometimes it is better, but it is only better for those tasks that are repetitive. So humans are normally much better in detecting hard things. For example, shadow in the lake, finding the time of the day in the image. These things are difficult things. Humans are better in these things. But computers can be sometimes better in finding the easy things. For example, in the image, if there are 10 things, trying to put a label on everything. So there is sofa, chair, table, bed, all these things. Computer vision can easily put a label or mark on these things. Clear? So computers are better only in those things that are repetitive but basic or simple tasks. So this can be exam question, that computers, they are better in repetitive tasks, and normally it is better in simple tasks, simple image detection tasks. Clear? But the complex tasks which are not mostly repeated, human vision is better in those tasks. So I think this is the first part of the lecture, and we stop here. Next time I will discuss what is being done. Some of the examples of the computer vision we will discuss in the next class. So we see you in the next class.